Hi, everyone, and welcome to episode number 6 of the Graph Show. Today I'll be talking with Olaf Hartig, author of a proposal called RDF-star. So on episode number 1 of the Graph Show, I had Jans Asman on, and we talked about RDF versus property graphs, the two predominant data models that are used with graph databases. RDF-star is kind of a reconciliation of the two, or a proposal to bring some of the advantages of property graphs to RDF, I would say, without losing the advantages of RDF. So maybe Olaf, could you just give us a quick overview of RDF-star, its purpose, and how it works?
Sure. First of all, welcome everyone. Thanks for having me on the show. So yeah, RDF-star, first of all, you can think of it really to be an extension of the RDF data model. So it is RDF plus an additional feature. And this additional feature, you can think of it to be, well, something that resembles the notion of edge properties that people know from the property graph model. Conceptually, what this extension does is it extends the notion of RDF triples in the way that now the first element of a triple, which we call the subject, or the last element, the third element of a triple, which we call the object in RDF, that these can now be triples as well. So you can have another triple in the subject position or in the object position of triples. Essentially, now you're able with RDF-star to nest triples into one another. And the idea of this comes from a long history of approaches and proposals for how in RDF we can capture statement level metadata or annotations on the level of individual triples, basically to capture use cases similar to what you have with the edge properties in the property graph model. And like I said, there have been lots of different proposals in this context. Now RDF-star is another one of these. The main difference, I would say, to the other approaches is that RDF-star basically starts from the question of why don't we use the triple itself when we talk about it in another triple. So that's why we really have this notion of nested triples. Other proposals, other approaches, they are based on introducing some notion of an identifier to denote the triple or the statement that you want to talk about. RDF-star really uses the triple itself. That's the key idea. So this idea has been floating around in the community since a long time. And now about a year ago, we have really formed a community group in which we are working on a community group report where we really are standardizing the approach. And the approach is not only about the data model, like the representation of triples and nested triples, but it's also about the query language, which, as I guess you know, for RDF, the query language is Sparkle. And the RDF-star approach also extends the Sparkle query language into something that we now call Sparkle-star. So again, this is really not just something different from Sparkle. This is really just Sparkle plus additional features, namely features that allow us to deal with these nested triples. And in particular, the idea here is that the basic element of a Sparkle query is a triple pattern. And in Sparkle-star, such a triple pattern may now again be nested. So you may have in the subject position of the triple pattern or in the object position of a triple pattern, you may have another triple pattern. And then you can easily see how this is meant to match the nested triples that you would have in the data. So that's in a nutshell the idea of RDF-star.
Sure, thank you for the overview. Can you give us some examples or an example of a use case for the embedded triples, and when sort of an RDF-star analog of edge properties would be useful?
Sure. I mean, there are lots of different use cases for basically whenever you want to make available additional information about a statement or about a relationship that you would represent by a triple in a graph. So very similar to the edge properties in a property graph. A concrete example, for instance, you can think of a let's say, a influence relationship between authors or between, I don't know, movie makers or whatever. So you have maybe, let's say, Stan Kubrick was influenced by Orson Welles. And this kind of influenced by relationship you can capture as a triple in your graph. So now you may want to add additional information about this relationship. For instance, let's say, for the sake of the example, you want to say you want to express some kind of significance of this influenced relationship, and that we may do by just representing this degree of significance of the influence with a numerical value. And so what we can do in RDF-star now is we would basically have the triple that says or Kubrick was influenced by Wallace, and then that one would be the subject of a triple with which we capture the significance, where then we have in the predicate position some property, some predicate that allows us to specify significance, and then we would have the numerical value in the object position. That would be one concrete example. Generally, again, it's really about any use case in which you want to provide additional information about, want to make additional statements about an individual statement. Other use cases would be to represent certainty scores, to represent weights, to represent maybe to capture temporal restrictions, provenance information, these kind of things.
Sure. There are some in the semantic web community, especially Henry Story, that have talked about sort of modality in RDF. So statements that are true in a certain sense, statements that were true at a certain time, that are true, according to some provenance. And it sounds like, RDF-star is perhaps a solution for those types of use cases, some of which are included in what you just said.
It's great actually that you bring this up, because I should also really mention that in the spec that we are defining, we are also defining the formal semantics for the data model. And one of the key features of this is that the idea of such an embedded triple is that this is not meant to be explicitly asserted in the graph, in which you have the nested triple that contains such an embedded triple in the subject position or in the object position, unless of course you explicitly insert the embedded triple as a triple itself into the graph. If you don't do this, then you can basically make statements about statements without endorsing these statements that you're talking about, which gives you basically exactly this feature that you've just mentioned. On the other hand, of course, you can still insert the triple, and then you also have the possibility to basically talk about triples that themselves are contained within the same graph.
Sure. Can you make higher order statements? So you have a statement about a statement. So you have a triple with an embedded triple either in the subject or the object. Are you free to then use that statement within a further statement?
Yes. So the abstract data model in RDF-star allows you to nest triples to an arbitrary level. And okay, similarly so also in the query language.
So that's something you can't typically do with property graphs. Are there any use cases out there for sort of higher order statements?
Well, probably the one that you kind of just alluded to. I mean, maybe I want to make a statement about the claim that itself is a statement about some statement. That sure. would be an option.
Sure. So, I mean, in some sense, RDF-star is more expressive than property graphs are.
Right. I mean, in that sense, it would be more expressive than what you would have in property graphs. Another aspect in which it is more expressive is that in the property graph, the edge properties, they are really just key value pairs, right? In the RDF-star context, if you have an embedded triple in the subject position of a nested triple, the object of that triple could also just be, again, a resource, like a thing that we are talking about. So it is essentially a node in the graph. You may even have two embedded triples, one in the subject, one in the object. So basically you're kind of connecting these and making a metadata statement that connects these two triples with one another.
Sure, and that's really powerful. Is there any danger of making this data model too complex, so it's too unwieldy, too difficult for developers to wrap their heads around? Jans and I talked about that briefly in the first episode. RDF is already considered to be somewhat complex. Now you're adding embedded triples. What is your take on that?
I mean, looking at this from the property graphs perspective, the edge properties are a feature that seems to be natural to developers and not difficult to understand. And in the sense, if RDF-star and at least these basic features that RDF-star provides that are property graph-like, if you present it in this way, I think it is not more difficult to understand than the notion of edge properties and property graphs. Of course, like we just said, it is even more powerful. But I mean, maybe as a starting user, you may not want to. You don't have to use these powerful features.
Yeah, it's kind of opt-in, and I agree that the idea of making a statement about a statement by attaching a statement to a statement is pretty intuitive, and maybe less confusing than other aspects of RDF, which are already part of the RDF standard. Can you speak to you mentioned alternative proposals. Would you consider named graphs to be one of those proposals, and specifically the ways in which named graphs were proposed in a few places for capturing provenance and trust and metadata about graphs and so on? So I think, yeah, could you compare and contrast a little bit?
Yeah, I mean, the named graph feature of the RDF data model has been used and has been proposed to be used to capture such statement level metadata. So really to capture statements on the level about individual triples. And the idea in this case would be to really have separate named graphs per triple that you want to talk about. And then you kind of use the graph name, and I would even say misuse the graph name within the metadata triples with which you want to talk about the triples, the single triple that is contained in such a named graph. And now when I say misuse, you may already notice that I'm not a big fan of this approach, because what it does, it basically, you can use it, but you are losing the option of also using the named graphs for making statements about whole sets of triples, which is kind of the actual use case of named graphs. You want to be able to make statements about whole sets of triples. And maybe even this whole set of triples may contain just a single triple. So then it actually becomes semantically difficult to distinguish between is your metadata now about a set of triples that happens to contain a single triple, or is your metadata really meant to be about the triple contained within the name graph?
Mm-hmm. You could use the graph level statements to not only wrap a single triple, but wrap multiple triples, right? So you could use name graphs in its intended way. Like I just said, I agree that sort of attaching a single statement to attaching statements to individual statements is a bit more intuitive. But you could say, okay, I have these two statements and they're both true in a certain time range, or they're both true according to what this one person said. So that you might think of that as a little bit of a generalization of RDF-star, a little bit more expressive than RDF-star, which
right.
Also but lets then, you get into.
Now you're starting to use name graphs for even yet another thing, which now it is not only for talking about a set of triples, but now you're also thinking about talking about individual triples. So making statements about individual triples, but basically grouping them together and saying, okay, these individual statements that these metadata statements that I'm making are meant to separately hold for each of these triples that you have in the set. Is that what you mean? Sure. I mean, it's
yes. I mean, you could think of the metadata statements as kind of distributing across them, or you could think of them as applying to the entire graph. So, like there was a proposal to use to define digital signatures for graphs, for example. That would be an operation that applies to the entire graph, not to the individual statements. But then if you're using them for provenance, probably you mean to say this statement was true at this time and this statement was true at this time.
Right. I mean, if you're using them for this type of provenance. On the other hand, you may also use them for provenance information about, I have retrieved this set of triples from a particular location. And then you're really talking about like the set as a set, not just about the individual triples. Perhaps. Or this set of triples is the result of some extraction process, maybe by some NLP extraction or something. And really all the triples together are the result.
Sure. So
one final thing I wanted to say, sorry. In the RDF-star spec, we are also extending the notion of an RDF dataset to an RDF-star dataset. So basically, we really also extend the data model so that now you have named RDF-star graphs, which contain nested triples, and then that basically gives you both options. You can talk about the individual triples using the RDF-star feature, but also you can talk about the set of such nested triples.
And have you defined some semantics for interpreting those statements? Do they distribute over the graph, or is that completely application dependent? What
yes,
they mean?
For the named graphs feature, yes, we didn't innovate in that.
Okay. As long as we're talking about kind of the range of alternatives, what about like quads, where you do have an identifier for each triple, or maybe even an identifier that can be shared between triples? How would that compare to RDF-star, where you're kind of passing a statement by value as opposed to giving it an ID?
I think that is very, very similar to RDF-star, with the main difference being that now you may have multiple different identifiers for the same triple. However, I mean, if you look into the RDF spec and then the Sparkle spec and all the related specs, there is no such notion of a quad. It's really just not formally defined. So it would really be about, first of all, inventing a whole new data model from scratch. I mean, it can have lots of these features that you also take from RDF, but basically a data model that is about sets of quads would be something new just from the start. And with the RDF-star approach, we are really taking the RDF data model as is. So basically a graph is a set of triples, and then we are extending this notion by now allowing these nested triples.
Okay, makes sense. Could you speak briefly to RDF reification as well? And why RDF-star is better?
RDF-star is different. I mean, RDF reification has the disadvantage that really for every statement that you want to talk about, you have to add 4 additional triples into your graph. So it basically may blow up the size of your graphs, in particular when it comes to exchanging this data. Within an RDF system, you may have some additional data structures that kind of allow these systems to avoid this blow up internally. But what I'm hearing from implementers is that it's very complicated to implement this and to get it done right, because in the RDF reification case, you also have to deal with all sorts of weirdnesses when it comes to parsing such data. Because what do you do if, let's say, 1 out of these 4 triples that you're expecting for the reification is missing from the data? What does this mean? Or if one of these, you have a duplicate of these with 2 different objects. So all of these weirdnesses you have when you're building a system and trying to deal with RDF reification. And then also on the level of the queries become much more complex, because not complex, more cumbersome to write. They have just many more triple patterns, because for all of these 4 additional triples, you also have to match them in the query, and therefore you have to include corresponding triple patterns in your query. So the queries become really long, really cumbersome to read, and really hard to figure out what's going on in the query.
Sure. Yeah, so those are interesting points. RDF, in principle, makes the open world assumption. So you can't assume that just because you don't know that you don't know the object for a given reified triple, that it doesn't exist and won't come along someday. So what do you do? Interesting. So I've seen a number of implementations of Sparkle Star and RDF-star that are either have been added to existing triple stores or are in progress. Can you give us any idea of who the current users of RDF-star are?
I have to admit that I have very little view into what the customers of the vendors are, but I mean, they probably for these questions, it might be better to really talk to one of the implementers. However, one thing that I have found recently is that the Yago dataset, which is a one of the well-known knowledge graphs, as of version 4, they are publishing their knowledge graph as a turtle star file. So essentially, they are publishing a RDF-star dataset. We have in the community group also users who are basically posting use case, not reports, more use case descriptions, which we are also collecting. But I really cannot talk about concrete things out
Yeah, sure. In the case of Yago, do you know what they're using the embedded triples for?
They have always had statement level metadata on one level. So they had a bit of provenance information, but they also had temporal restrictions for some of the relationships that are in the triples. So they always had this, but they had some custom-made CSV, 4-column CSV files before. Something like more like a quad serialization, and now they have gone to this triple star format.
I see. Do you know if they're using Sparkle Star in combination with that?
I mean, they are just publishing it. They are publishing the data set. I don't know whether there's a public endpoint for that Yago provides.
So I know that RDF-star and Sparkle Star are proposals in progress, and you're not claiming or promoting them as the next version of RDF. That's all to be determined, how RDF-star and Sparkle Star figure into a future standard. But they are kind of being touted by some graph database vendors as the next version of RDF. Mm-hmm. Can you speak to just kind of this current state of the proposals and where you see them going?
Mm-hmm. So, I mean, like I say, that we do this in the context of a W3C community group, and such community groups are basically, we can publish such types of reports, but these types of reports would basically be an input to a possible future working group, which then can create a recommendation or can extend an existing recommendation. So what we basically want to do in the community group now is to really complete this report and really think that this can be a very valuable input to a future working group. But it's not only the completion of the report. There also need to be implementations. So then I think now it's also up to the implementer, and in particular to these vendors that you mentioned, to all come to really all implement the approach in the way it is defined in the report, and that I guess would also increase the value the importance of this approach within the future working group.
Okay. Yeah, while you're speaking, I had one additional kind of a question about expressivity, which occurred to me. When would you use RDF-star for use cases relating to provenance or modality, or any place where you might want to make statements about statements, versus using vanilla RDF, but in combination with a vocabulary that somehow encapsulates provenance. So instead of having a statement that one movie director influenced another, and that is true to a certain degree, you could also kind of reify that and have reify the relationship, say, call it influence. And there are properties that attach to this influence class, and one of those properties is a weight. So when would you want to use this more kind of generic RDF-star approach versus building vocabularies that encapsulate that provenance or that modality?
Mm-hmm. So I mean, what you mentioned there would be n-ary relation, like objects or entities that represent n-ary
more than
relations,
binary.
right? Mm-hmm. Yes, and in that sense, RDF-star is really kind of a special case for the binary setting, where with the binary you want to basically annotate the binary relationships. I think it depends really on the use case and on how within a use case, within a modeling use case, how important is if it is a binary relationship for which you want to have additional like, let's say, auxiliary information, versus if it is a ternary n-ary relationship where more than just two elements that are related to one another basically have the same kind of importance for the relationship. Then obviously it makes sense to model it really as a separate entity that represents the relationship itself. If it is a binary relationship, you can still use the n-ary relation approach, but you can also use RDF-star, which I would think may be more natural also to people coming from the property graph world, but also for people really thinking in terms of these binary relationships with maybe some additional information.
Sure. It kind of also allows you to treat the schema for the embedded statements as a black box. You can have, say, a vocabulary about temporal assertions, or you can have a vocabulary about provenance that doesn't know anything about the statements that you're claiming that occurred within a particular time or had a particular provenance.
Right, and coming there, maybe we can come back again to the way the semantics of RDF-star is defined at the moment. The way it is done is that the embedded triples are treated actually as opaque, meaning that let's say if you have this example again with Kubrick influenced by Wallace, and if somewhere else you know that you have another URI that identifies Kubrick, it is not possible to simply derive another nested triple in which the Kubrick URI would be swapped out. Okay, so that we really treat the embedded triples more like literals.
Mm-hmm.
Having said that,
so what is that? I'm not sure I completely followed that. So what is the what are the implications of that? Like, when would that make a difference?
It makes a difference, let's say, more for the provenance type use cases, where I really want to make a statement about exactly that statement, about exactly the statement in the form as it is given that I annotate. So some particular URI that identifies Kubrick influenced by Wallace. And I want to make statements maybe about this specific triple rather than about the statement that this URI identifies Kubrick and I can actually use any URI that identifies Kubrick.
Yes, okay, I think I get it now.
Nonetheless, it is possible based on this semantics in which the embedded triples are treated as opaque. It is also possible to treat them for particular properties in the metadata to treat them as transparent. So you basically then would simply have to define the semantics for specific metadata properties for which then you can use reasoning to also like derive the triples in which, let's say, the UIs would be exchanged.
Okay, so there's a lot of nuance in the semantics. Anything else you'd like to say about? I know there are a lot of open questions. I haven't been following the mailing list very closely, but what are sort of the other topics of debate with respect to semantics right now?
I think, I mean, these have been the main discussion points really in the group. On the one hand, this idea that the embedded triples are by the base semantic by the semantic that we define are treated as opaque. The other thing is that the embedded triples are not meant to be asserted in the graph unless you explicitly add them. These are the main, I think, discussion points that we had. And in my opinion, we have chosen the options that are the least intrusive. So the ones that you can still extend on top of them. And the respective other options for them, you can basically, let's say if for this case where we say an embedded triple is not explicitly asserted unless you really, no, sorry, an embedded triple is not implicitly asserted unless you explicitly put it into the graph. The alternative option would be whenever you have an embedded triple, then it is also considered to be asserted, even if you don't have the triple in the graph itself. So now, if you would have this semantics, then there is no way of talking about triples without endorsing the statement that the triples make.
Right. Yeah, I don't see why you would want that if you want to support like the modal use cases that we kind of alluded to. Okay. Do you have any thoughts on GQL? So and you said that RDF-star is an enhancement of RDF. It's really built on top of RDF. But then there's GQL, which eventually will have a schema language that supports properties on edges. How do you see kind of RDF-star interacting with GQL in the future once there is a standard?
I mean, first of all, GQL is a query language. RDF-star is a data model. So maybe the question would be more on probably more on the notion of a property graph as defined for GQL, I guess, right?
Yes.
Yeah.
So query language combined with a schema language.
Yeah. I mean, for the data part, I think and I hope there will be coexistence of the data models, and having this additional feature in RDF, like this notion of nested triples, which basically allows RDF to be more like property graphs, really I think is a key element for also bridging the gap between these data models. And similarly on the query language level, having this feature to be able to really access edge properties from within queries, so which you can think of these nested triple patterns to be such a feature, again, is a way of bridging the gap to property graphs. So in fact, I've already published one research paper in which I'm defining a formal query semantics for Sparkle Star to be evaluated over a labeled property graph. So really a formal foundation for being able to use Sparkle Star as a language to query property graphs. And in the same way, I mean, I understand that GQL, of course, will be different language, but so I still see and hope for that this approach, RDF-star Sparkles, that really allows us also to build bridges between the different types of systems and types of graphs.
And it's going to be really interesting to see how all of that develops. I look forward to continuing to follow your work, Olaf, and that of the community group. What's the best way for folks to get involved if they're interested in all of this? Join the group?
I mean, that would be great. Sure. I mean, so we have. I guess you can put the link to the community group website into the chat or whatever you have. Right. Exactly. There you will find the pointers to, first of all, the published versions of the draft. We have 2-3 days ago released the second public draft version, which is fairly complete already. There are still a few things that need to be polished and that need to be discussed. But I mean, I think it is in a shape that it allows really people to go in and read it and really take it apart and ask questions about the details. You find links to our GitHub repo where you can open issues and really discuss the details of the draft. And obviously, we would like to see implementations now. And there's also a way of posting implementation reports. We have a huge collection of test suites for all the extensions of the RDF serialization formats, or for many of the serialization formats. Since we are also extending these ones, we have test suites for parsers for such serialization formats, and of course we also have test suites for Sparkle, star, syntax, as well as evaluation tests. And there is actually a way for creating implementation reports that allow you to see how many of the test cases your system already gets right and which ones not yet. And so we are really looking forward to getting feedback on the draft as well as seeing implementation reports coming out.
Awesome. So many different ways of getting involved if graphs are your thing. Thanks again for being on the Graph Show, Olaf.
Thanks for having me.
For everyone else, thanks for watching. For past episodes, check out datageeks.tv.